Hello friends, in this video I'll discuss question on classical mechanics appeared in assistant professor examination. If the Lagrangian of a system has only one term which has a linear dependence on velocity, then it's Hamiltonian. Options are also has only one term depending on velocity, is zero, is not defined, is independent of velocity and is constant. So given that Lagrangian of a system has only one term which is linearly dependent on velocity. So let L be k into x dot, where k is a constant and L is linearly dependent on velocity x dot. Then Hamiltonian H can be written as, so H is given by summation of q dot p minus L, where q dot is generalized velocity, p is generalized momentum minus L, that is Lagrangian. So here given that it has only one term, that means H can be written as x dot px minus L. Here px, that is generalized momentum, is given by dou L by dou x dot. So L is kx dot, therefore dou L by dou x dot will be a constant k. So if you substitute this in expression of H, you will get x dot px is k minus value of L is kx dot. Therefore H will be 0. Option B is the right answer. A system exhibits invariance under translation in space and time. The following quantities will remain conserved. Options are linear momentum and angular momentum and energy, linear momentum and energy, linear momentum, angular momentum and energy. So given that a system is invariant under translation in space and time. Translation in space, if it is invariant under translation and in space, means linear momentum is conserved. If it is invariant under rotation in space, then angular momentum will be conserved. And invariant under time means energy is conserved. So here invariant under translation in space and time, therefore linear momentum and energies are conserved. Option C is the right answer. A particle is moving on a sphere of fixed radius. The number of degrees of freedom for the particle will be, degrees of freedom is minimum number of independent variables required to describe the position of a system. So here given that a particle is moving on a sphere, so consider a sphere. A particle is moving on a sphere, so only one particle moving on a sphere. So in order to describe position of this particle, we need three coordinates, r, theta and phi, and given that sphere has fixed radius, so you know that sphere has fixed radius, so r will be constant, that is a constraint, only one constraint. Here we need 3 degrees of freedom to describe the position of particle on a sphere. So 1 is fixed, so 3 minus 1, therefore degrees of freedom will be 2. Which of the following observers is non-inertial? Options are a child revolving in the merry-go-round, a driver in a train moving with constant velocity, a man at rest. It is difficult to make a unique statement of inertial and non-inertial aspect. So we know that the revolving, that is rotating frames, are non-inertial frame. So here option A is the right answer. The product of any generalized momentum and the associated coordinate must have the dimension of. So generalized momentum P is always having the dimension of momentum m into v. Then its associated coordinate, that is generalized coordinate q, will have the dimension of r. So product of these two will be mvr. So that will be having the dimension of angular momentum. Next question is, scleronomous constraints are, options are independent of time, dependent on time, both independent of time and dependent on time, equivalent to rheonomic constraint. So we know that rheonomic constraints are always dependent on time and scleronomous constraints are independent of time. Therefore, option A is the correct. The Hamiltonian corresponding to the Lagrangian L is equal to ax dot square plus by dot square minus kxy is. 4 options are given. Lagrangian is given. You need to find out the Hamiltonian. So we know that the canonical momentum px is given by dou L by dou x dot. So L will be x dot plus by dot square minus kxy. So differentiation of L with respect to x dot is 2x dot. Then py, that is canonical momentum, dou L by dou y dot is equal to 2by dot. So h is equal to summation q dot p minus L. So here two terms are there depending on x and y. Therefore x dot px plus y dot py minus L. So if you substitute the value of px, py, you will get px square by 4a plus py square by 4b plus kxy. Therefore option C is the right answer. The Lagrangian of a free particle having rest mass m0 and relativistic speed v is given by. Lagrangian of a relativistic particle is given by minus m0 c square into square root of 1 minus v square by c square minus m0 square root of c square minus v square divided by c square. If you simplify this one, you will get minus m0 c square root of c square minus v square. Therefore option D is the right answer. According to special theory of relativity, a particle cannot travel with the speed of light because its velocity will soon be infinite, mass will be infinite, mass will reduce, mass will be zero. From special theory of relativity, m is given by rest mass m0 divided by square root of 1 minus v square by c square. So here, if velocity of particle is equal to speed of light, so if v is equal to c, here this term will be is equal to 1. So 1 minus 1, 0. M will be m0 by 0, that is infinite. Therefore, if a particle travels with the speed of light, mass will be infinite. Therefore, particle can't travel with the speed of light. Option B is the right answer. The value of Poisson bracket x square px square is, here x square px square can be written as x square and this px square as px. From the property of Poisson brackets, if it is ABC, then Poisson bracket AB into C plus B AC. Using this property, this can be written as x square px into px plus px x square px. Then Poisson bracket of x square px can be written as differentiation of this x square, that is 2x into Poisson bracket x px. Therefore this will be 2x xpx into this px plus px 2x xpx. Then value of x px is 1. So simplifying this one, you will get answer 4x px. Therefore C is the right option. The Lagrangian of a system with 1 degree of freedom is given by L is equal to alpha q dot square plus beta q square, where alpha and beta are non-zero constants. If PQ denote the canonical momentum conjugate to Q, then which one of the following is correct? So given L is given, then PQ is the canonical momentum conjugate to coordinate Q. Here momentum PQ can be written as dou L by dou Q dot. That is differentiation of L with respect to Q dot will be 2 alpha Q dot. Therefore value of PQ is 2 alpha Q dot. Then so in C and D option PQ is 2 alpha Q dot. Then in option C it is given that it is conserved quantity, and option D it is given that it is not a conserved quantity. To check this one, we need to write the equation of motion, that is d by dt of dou L by dou Q dot minus dou L by dou Q is equal to 0. So dou L by dou Q dot is 2 alpha Q dot, then dou L by dou Q is 2b 2 beta Q. So if you simplify this one, d by dt of PQ is equal to 2 beta Q. So if differentiation of PQ with respect to time is equal to 0, then we can say that PQ is a conserved quantity. Since it is not is equal to 0, PQ is not a conserved quantity. Therefore option D is the right answer. The force vector corresponding to a potential V is equal to kr cube, where k is a constant. So here potential V is given, so we need to find out the force vector. F is equal to minus dou V by dou R. So differentiation of V with respect to R will give minus 3k r square into unit vector R. We know that unit vector R is equal to vector R divided by its magnitude. So if you simplify this one, so minus 3k r into vector R. Therefore option A is the right answer. For a single particle under a central force which varies as r square, the average kinetic energy T and average potential energy V obey the relation. So under central force, we know that virial theorem. So if V is proportional to R raised to N, then average kinetic energy T can be written as N by 2 into V, where N is the power of R on which potential depends. So here central force is given. Force is proportional to R square. So we know the relation between force and potential. Potential V can be given by integration of F into dr. That is integration of R square dr. R cube by 3 dr. That means R cube by 3. That means V is depending on third power of R. Therefore the average kinetic energy T can be written as 3 by 2 into average potential energy. Therefore option B is the right answer. A particle moves with a constant velocity parallel to x-axis. Its angular momentum with respect to origin is. So options are 0, constant, increasing, decreasing. So here if you consider this as x-axis and this as y-axis, given that velocity is constant. That is, particle is moving with constant velocity v parallel to x-axis. This is the origin. So it is constant and parallel to x-axis. That means this distance is constant. That is, r is constant. So angular momentum is given by mv into r. So v is constant, m is also constant, r is also constant here. Therefore angular momentum with respect to origin is also constant. Thanks for watching. If you like this video, please share, like and subscribe.